So we are going to start with a definition, a mathematical definition. What's special about a hyperbola? It's going to be reads very similar to our other two mathematical definitions for parabolas and ellipses. Of course, the one thing that's going to change is what's that characteristic. Okay, a hyperbola is a smooth curved graph in which the difference of the distance from a single point to the two focus points is constant. So instead of the sum, it's the difference. While we don't necessarily use these definitions to graph or to write the equations, the definitions are those special characteristics that make these things useful in applications. Before I move on and get to the equation slide, I'm going to just show the bottom here, which is going to be basically the same picture that you have in front of you for the perfect hyperbola. And I'm going to talk about a change in vocabulary, which is instead of talking about major and minor axes, where we have something called a transverse axis. Okay. So the transverse axis is the line that contains the vertices and the foci of the hyperbola. Vertices and foci, if you'll remember from yesterday, were on the same axis for an ellipse. The vertices and the foci, the A's and the C's, were on the major axis of the ellipse. Okay. And so the vertices and the foci are still on the same axis. Okay, and they're going to be on something called the transverse axis. The transverse axis is the axis like that your hyperbola opens up around. So if you have your perfect hyperbola oriented like the same way that I have it here on the screen, and we look at it like it's opening left and right, you can see in our marks, we have the vertices for each of the branches. Okay, so the place where they turn around. And then they open around the foci, just like a parabola opens up around the focus point. And we have basically a horizontal transverse axis. Okay. If you were, and you could do this, you have that perfect hyperbola right in front of you. If you were to take your sheet of paper and rotate it 90 degrees, you have now created a hyperbola that opens up and down. The vertices and the foci are on a vertical axis, so then that's what a vertical transverse axis would mean. Okay? So the difference between vertical and horizontal transverse axis is like what direction does your hyperbola open. Other things that we're going to talk about on the next slide when we go through the characteristics of the hyperbola. Obviously, we're going to talk about A's and C's again because we have vertices and foci. There is going to be a center point. You could imagine where the center point is for the hyperbola. Okay, on my graph of the perfect hyperbola, it's at the origin there. And then another thing that we're going to address is in order to help us draw the shape of our hyperbola, hyperbolas have two asymptotes. And so when we talked about rational functions long ago, where it looks like a fraction, the simple rational functions are hyperbolas. They have two branches. And we kind of had to decide, like, where are our two branches for our graph, right? In what, like, little sections. This has two branches. It's also the hyperbola. There are still two asymptotes. Big difference in conic sections is most likely they're going to be slanted. So imagine where the asymptotes are. What's the line that the graph is approaching but never actually touching? One of your asymptotes is a line that is falling from left to right. And the other asymptote is a line that is rising from left to right. Notice that both asymptotes cross through which point? The origin, which happens to be my center point. Okay, so we're going to use that fact that it passes through the center point to help us write the equation of the asymptotes. Okay. Also notice how like when we draw in the asymptotes right there, that's how you're going to be drawing your hyperbola. Your hyperbola should follow your asymptote. Okay, so it's really, really close to the asymptote. That's what it does. Okay, so that will help you draw a better hyperbola. Okay. Okay, so this is what you actually want to write down for equations of hyperbolas. Notice I'm changing the vocabulary there. Instead of a horizontal major and a vertical major axis like an ellipse would have, we have horizontal transverse and vertical transverse. Okay, transverse axis is the axis on which your hyperbola opens. As you're writing down those two equations, you have to pay careful attention because they look a lot like ellipses, but then there are some key differences. What are a couple of the differences that we're seeing? Lily, one of them?
They're being subtracted instead of added.
Okay, yeah, so this is going to be a key way for us to determine, like, am I supposed to be graphing an ellipse or am I supposed to be graphing a hyperbola? If one of your squared terms is negative, if x squared and y squared are both or x and y are both squared, and one of them is negative, then it's a hyperbola. Okay, so they're being subtracted. Other differences?
The h and the k, they're switched around.
The h and the k, like the x minus h and the y minus k, are switching in the numerator, whereas a squared and b squared are stuck, right? And then if you look back at your ellipse, x and y always stayed in the same, but we switched the a squared and the b squared. So that's going to change some things for us in our characteristics. H and k are still going to represent the center point. Okay. HK will always come in that order. H is the x coordinate, k is the y coordinate. So you'll have to pay careful attention if it looks like y squared minus x squared. You have to write your h first and then your k. So it goes out of order. The big difference here from an ellipse is how do you find a? Remember that for an ellipse, a squared and b squared were moving around. How are we going to tell which one was a squared? Yesterday we said a squared was always bigger. Okay, that may not always be the case for a hyperbola. Now we just say a squared is always first. Okay. A squared is always first. A squared is always paired with the positive one. We always have, like someone mentioned, the minus. Lily told us that there was subtraction there. So a squared is always with the positive, b squared is always with the negative one. A still represents the distance from the center to a vertex. Okay, so if we're asked to find vertices, we're still counting out A's. C is still the distance from the center to the foci, so we're still counting out C's from the center point. A and C are still friends, so they still belong on the same axis. Instead of being on a major axis, I could circle both of these and say they're on the transverse axis. You still decide what direction to go based on like what coordinate it's paired with. So if a squared is always first and you start with an x minus h squared, then you know to count left and right. Okay, and you'll have a horizontal transverse axis. If y minus k squared is first and paired with a, then you know to count up and down for a and c. Okay, so still that way of like, how do I know what direction to count, is still with whatever letter it comes with, whatever coordinate, x or y. Okay. And then notice that the c squared is different. Back to what we would think of more like a Pythagorean theorem. C squared equals a squared plus b squared.
Wait, so could you draw real quick what the horizontal transverse would
Yep.
look like?
Opens right and left horizontally versus vertical transverse axis will open up and down. And they may not be centered at the origin so they could move, but it's just what direction it opens. question. Anything else that you want to ask about on this slide? We will still use B, even though I haven't written B down. I'm not going to call B co-vertice because yesterday in the ellipse, we actually used the B to like turn our ellipse. Okay? B we're going to draw B. We're going to use B to help us make the asymptotes. But B is not even really part of the hyperbola. Okay, so we don't have a name for B anymore. So I'm just not going to say anything about B, but we can still find it. Okay, next slide before our example is just really quickly about the asymptotes. Okay. Now, when you're writing the equation of the asymptotes, I'm going to say the easiest way to do this is to use your point-slope form. And you can leave it in point-slope form. You don't have to do any distributions and combining of like terms to get to slope-intercept. Point-slope form is the one that looks like this, y minus y1 equals m times x minus x1. And we're going to fill in for that. I'm going to write these things down so you know like what should like a form of my asymptote look like. These I'm going to tell you in the example. I would not necessarily memorize the slopes. I would just count out my slopes in my example, just like I did for the parabolas, focus, and directrix. I wouldn't memorize h plus p comma k. I would just count it out and label it. Okay, so I'm going to do the same thing for asymptotes, but we'll at least write them down. We're going to plug in for the x sub 1 and the y sub 1. What point do we know that our asymptote is going to cross through? The center point. So our x sub 1, y sub 1 is basically going to be h and k. Okay? So we know that we're going to replace those with h and k. The big thing we have to decide is like, what is my slope going to be? Okay? So I'm going to start with a horizontal transverse axis hyperbola. Remember, horizontal transverse axis is the one where x comes first, x minus h squared over a squared minus y minus k squared over b squared. And I'm going to set up, remember we're going to use h and k for x and y, so I'm going to have y minus k equals, and then I want something for my slope. I'm going to leave my slope empty for right now, and I'm going to leave a little space there. I'm going to put x minus h. Okay, so every asymptote that you write will have that y minus k, x minus h piece, okay, for whatever the center point is for your hyperbola. Okay, in the slope, remember that on that picture that I drew, your perfect hyperbola, there were really two asymptotes. One is falling from left to right, one is rising from left to right. So you have one with a positive slope and one with a negative slope. But otherwise the slopes are going to be the same. So I'm going to put a plus or minus. And then the big thing that I have to figure out is, what is my slope? Okay. Well, when you think about slope from probably algebra 1, slope we would say from algebra 1 is just rise over run. Okay? So what you need to do is think about when you plot points from your A, B's, and C's, what's your rise over run? Okay? So looking at your A squared and your B squared, which one of these goes up and down? A's or B's in this equation? You count up and down A or up and down B?
Up and down.
Count up and down B because it's paired with Y's. Okay, so here I know that I would rise B units and I would run A units. So if I think about my rise over run, it would be B over A. If I do a switch of my transverse axis, then I'm now changing which unit I rise with. Now I rise with A and I run with B. So then my slope would be A over B. Everything else about the asymptote would be the same. And again, would I memorize this? No. I'll just count it out. But I want to write it down so you know, like, of the possibilities, it should be one of these forms. It'll have the y minus k, it'll have the x minus h. and then you should have a plus or minus because there are two of them, and it will either be for a slope B over A or A over B. You've got to decide which way you're counting up and down, which way you're counting left and right. Okay, so let's do an example. Yes.
Can I go now?
Is that what time you said?
I'm ready.
Thanks for asking double permission. X squared over 9 minus y squared over 25 equals 1. Find all the things. I start this a lot like I start my ellipse. I want to know where to count out from. So I want to know what's my center point. What's my center point here? 0, 0. Oh, I love that. That's easy. So I'm going to plot that. Then I'm going to do the same work that I did for the ellipse, which is like do A's and B's and count out. A is what?
What?
Why?
Well, since 25 is larger, it's the A. So, in the square root of 25 is what?
That's for the ellipse only. This is A stays the same. It's just the X and the Y.
And then
Flip back to. What'd you write down? A squared is always? A squared is always? First. Did you write that down? Okay. Just checking. So A squared is? Well, A squared is 9 and A is 3. Very good. Which means B squared is 25. So that old rule changes. Okay, so you have to be really careful. There are some similarities between ellipses and hyperbolas. But you have to be really careful. There are some big differences. Okay. Okay, so I'm going to count out in those directions. For A is paired with X, so I should count 3 in what directions? Right and left. If it's with X, I should be counting in the direction of X, which is always left and right. So I'm going to count 3 to the right and 3 left. And those are going to be, I'm going to label those are my vertices, so I can kind of keep track of things. Then I can label my vertices right now. You could write 3, 0 and negative 3, 0. On this one, it would also be acceptable for you to write plus or minus 3, 0. It's 2 and 1. I'm still going to count out my B's, so I'm going to go up 5 and down 5. Those aren't really going to be points on my hyperbola, but they're going to help me with my asymptote. Okay. So here's how you're going to work the asymptote. You have these 4 points that normally, if we were doing an ellipse, we draw a round shape. We're going to use those 4 points to draw a rectangle. Rectangle, not a diamond. Okay, so it's not a rectangle like connecting the 4 as corners. We need right angles. Okay. Draw a little rectangle right there with those 4 points. You're going out 3 in both directions. You're going up 5, up and down 5 in both directions. Okay, your asymptote are the diagonals of that rectangle. So they pass through the center point, and then they pass through the corners of the rectangle. So you can use that to help you draw asymptotes nicely. Okay. So the rectangle helps us get our asymptotes. I could use that then I know that I want to label my asymptotes. I could use that then to get that point slope form for my asymptote. Remember, it will be y minus k, which is y minus 0, or just y, equals plus or minus, and then I got to figure out, is it a over b or b over a? Am I going to memorize it? No, that's too much to know, right, for every single conic section. I'm going to look at my graph. How many did you rise from your center point? 5. How many did you run? 3. To get to that corner spot, so your slope is 5 over 3. And then you would multiply it by the quantity x minus h, which is x minus 0, or just x. If you had like a center point, then you would just like put like x minus 3, but you don't have to distribute, just leave it alone. I could also, at that point, if I wanted to, I could draw my hyperbola. You can draw your hyperbola at any point once you have your asymptotes and your vertices. When I check your hyperbolas, I want to see that your hyperbola is actually getting closer to your asymptote. So if I were to draw my hyperbola, I would start at my vertex, and then I would approach my asymptote on both sides. If you were to draw for me a hyperbola that looks like that, I'll take off. Like, that does not look like it's getting closer to an asymptote, nor does it look like it ever will. Okay, it's or maybe a different set of asymptotes is what it looks like. So you actually like follow your asymptotes. Okay, Lexi.
Are we gonna find out foci?
Yes. Yeah. Lexi, of course, wants to find all the things. So she wants to know, where are those 2 focus points? We know they're out here past our vertices because we got to open up around the foci. So what's the connection for C in a hyperbola?
C squared equals A squared.
Okay, here would be another big difference from that thing we talked about with Dylan. A squared is always first. Then when you calculate C, it's a different equation. Instead of A squared minus B squared, it's A squared plus B squared. So that would be C squared equals 9 plus 25. That's C squared equals 34. So C is the square root of 34. On my graph, I would just do that estimation thing. Like, I know the square root of 34 is right below the square root of 36, which is 6. So I want to count out just a little bit under 6 from my center point. So my center point was at 0, 0. I got a focus point right before 6, 0. And a focus point right before negative 6, 0.
Do you want us to draw the focus point?
Yes. Yes, so like think about parabola should have graphed a directrix and a focus. An ellipse should have 2 focus points. A hyperbola should have 2 focus points and an asymptotes. Yes. And I need to label those focus points as well. Okay, so what are my foci? If I had a center point, I'm just adding and subtracting the square root of 34, which cannot be reduced to the value of x, because I'm going left and right. On this one, my value of x is 0. So I could really just write plus and minus square root 34, comma 0. If, let's say, our center point was at 5, 1, I could write 5 plus or minus square root 34, comma 1. Or you could do 2 separate ones. 5 plus square root 34, comma 1. 5 minus square root 34, comma 1. Any questions, concerns? Okay, the last thing that we need to talk about before you are set free on your own for hyperbolas over the weekend is how do you change them from that general form to the standard form? So like the worm.
General form?
It'll be your favorite at the end. I think maybe. I should have a magic 8-ball to see.
Well, I got one of those for Easter.
I thought you had one in your bag.
I wish I hadn't.
I should carry one around and let it make my decision for me. That would be a nice way to end the school year, wouldn't it?
I think Sheldon Cooper did that once. It was kind of bizarre.
Oh, you make it for.
I feel like it would make for a really interesting day.
Like,
Should
he
go to
like
school today.
offloaded all his big leadership
I don't think
to
so.
Magic 8 Ball. Sort of scraping line and other things. It was.
Yeah. The kids asked me a question, can I go to the bathroom? Okay, get up and look. If you don't want your Magic 8 Ball, I know someone who might like it.
What? Last day of school, I should use that.
Dylan's
Oh,
toy.
sign up.
Yeah, why not? I mean,
Should I get up this morning?
well, no.
If I gave you a magic 8 ball, could I ask the question, will you give me an 8?
You could ask it. What is the validity of the Magic 8 Ball? I'm not sure. Yeah, I better be careful with what I allow. Okay, the first step to this would be that whole thing that we did in the warm-up, which is group your y's together and your x's together. Now notice that I'm putting y squared first because it's the square that's positive. Okay, so I always want my positive one to be first and my negative one to be second when it's a hyperbola. And I could tell, we're going to talk about this on Monday, I could tell that's a hyperbola because when I look at the equation, I have a y squared and an x squared, but one of them is negative. Okay, automatically a hyperbola. Now, you're going to do just the same thing that you did in the warm-up, which is you'd like to complete the square, but you have a hard time completing the square when x squared and y squared have coefficients other than 1. So you need to factor those things out. So in the y's, I have to factor out a 16 from both. That would be y squared plus 4y. Leave space to complete the square, and you're going to have to distribute your 16 to that number. Okay. This is really tricky with the hyperbola. Even if x doesn't have a coefficient, or the y squared doesn't have a coefficient, but it's negative, you have to factor out the negative. So like if that said negative 2x squared, I would factor out negative 2 from all my x's. Since that just says negative x squared, I'm going to factor out a negative 1 from all my x terms. Okay, so I'm going to bring out the negative 1, and that leaves me with a positive x squared and a negative 2x. That makes a big difference in your final equation for like what does your x minus h look like? Is it minus or plus? If you forget to take out the negative from the second term, then you'll have your hyperbola in the wrong spot. Okay. So go ahead and complete the square for each. Okay, hopefully you're getting better at completing the square, right? Take half the middle term and square it. So the first number that completes the square over here is 4. When I put plus 4 there, I really added 64 on the left. So now I have to add 64 on the right. Gotta keep that balance. Golden rule of algebra. What I do to one side, I have to do to another. The number that completes the square for my x's is plus 1. But what I really did was subtract 1. That's really negative x squared plus 2x minus 1. So I gotta subtract 1 on the other side. I really subtracted 1. And then simplify. So keep my 16. Simplify this. This would be y plus 2 times y plus 2, which is just y plus 2 squared. Keep my negative 1, and then x minus 1 squared. And then this should be 16. Did I do my math correctly?
So you went from y squared plus 4y. How did you take out the other y?
Factoring. What factors of 4 add to make 4y? 2 and 2. So if you FOIL that out, that's y squared plus 4y plus 4. Are you okay with 16?
Yeah, I don't know why, but like my mind wasn't wrapped around it.
Divide everything by 16. And then you have standard form. So then it becomes very much like an ellipse. That's just y plus 2, quantity squared, minus x minus 1 squared over 16. At this point, I could drop my 1, okay, if I wanted to, and then it equals 1. I could now identify the center point and the a squared and the b squared. What's my a squared on this one? 1. So a is 1. Okay. Something for you to like look at when you're doing your homework assignment is like think about like how far away your focus is from your vertex, and then like what does that do to your hyperbola in terms of width? Like is it a wider hyperbola or a narrower hyperbola? We kind of looked at, I think Nick had the skinnier parabola because his focus was closer. Okay, so try to imagine what that would look like. You do have a homework assignment over the weekend. Okay, 5 through 8, just like our previous assignments, is matching. And so you're really only graphing 4 hyperbolas. So it'd be a real shame if I have to walk around class on Monday and circle people for not having homework.